Alright class, today we're going to talk about equivalent fractions. I'm going to go ahead and write that at the top. That's your title for this section. Make sure I got that right. Equivalent fractions. Okay, and we want to put a little equal sign right here so you know that it means fractions that are equal, right? So let's go ahead and talk about this definition real quick. So these are fractions that look different, but have the same value. Okay, so again, that's his depth. These are fractions that look different but have the same value. Okay, have the same value. Make sure you got that written down. Okay, now we want to get into a certain type of equivalent fraction that I call different forms of 1. Okay, different forms of 1. What I mean by that is, let's say we have the number 1. Okay, the number 1. And that's equal to, let's talk about something that probably one of your elementary teachers said. Okay, so let's say we have 7 divided by, and remember that fraction, I want you to draw the fraction line. That fraction line, 7 divided by 7, right? 7 divided by 7. So let's say you have 7 apples, and you divide it between 7 people. How many apples will each person get? 1, right? 1. And then let's say you had, I don't know, $10, and you divide it between 10 people. How much would each person get? You see how these are all different forms of 1. They're all the same value. 7 divided by 7 is the same thing as 10 divided by 10, right? Even 200 divided by 200, also 1, right? You can go all the way up to 1,000,000. You can even use variables, which we'll get to later. X divided by X. You haven't seen that before. It's just something new. It's something I want you to write down, right? X divided by X, even X plus 3 divided by X plus 3, right? Anything divided by itself is 1. You've heard that before from your elementary teachers. And also, I like to do this one. Dinosaur divided by dinosaur is also 1. Okay? Anything divided by itself. Okay? Anything divided by itself is 1. Alright, let's go ahead and get into some examples. And so remember, our definition that we have is that equivalent fractions are fractions that have the same value but look different, or look different, have the same value, however you want to say it, okay? So our first example we're going to have is 3 over 5, okay? 3 over 5. Now, remember that old saying in elementary, whatever you do to the top, you have to do to the bottom, right? Whatever you do to the bottom, you have to do to the top. And we're still going to use that idea here to form these equivalent fractions. So again, you've dealt with equivalent fractions probably since 4th grade, okay? And so now we're trying to come up with a fraction that's equal to this fraction, right? And we're just going to do something simple. We're going to start with the number 2, right? And so we're going to multiply the numerator, the top number, by 2. This right now. And so we have a 3 times 2, whatever you do at the top, you have to do the bottom, times 2 as well. So 3 times 2, we're going to get 6 in our numerator. 5 times 2, we're going to get 10 in our denominator. Okay, so what that means is we first start off with 3/5, right? That's our first fraction we start off. Then we wanted to find an equivalent fraction. The way we do that is you have to multiply numerator and denominator by the same number. We end up with 6/10. Now, these are equivalent because, again, they look different. But if you were to type this in the calculator, 3 divided by 5, 3 divided by 5, right? When you were to type 6 divided by 10, right? 3 divided by 5 or 6 divided by 10, right? You would still get 0.6. You would still get 0.6. Okay, you would get this decimal value, and they're the same decimal value. So, again, they look different, but they have the same value, okay? Same value. Okay? All right, good. All right, let's go ahead and I'm going to do another example. All right, so the way you can multiply, you can also reduce or simplify. You did that in 4th grade as well. So let's say you have 25 over 50. 25 over 50. And we got to figure out a number that goes into both of these that we can divide them by. Well, of course we can do 5, right? Let's do 5. So divide top and bottom by 5. 25 divided by 5. So again, whatever you do the top, you have to do the bottom. 25 divided by 5, we get 5. 50 divided by 5, we get 10. Are we finished? No, because I can still think of a number that goes into 5 and 10, which is the number 5 again, right? And so we're going to divide the top by 5 and the bottom by 5. We're going to end up with 1 over 2. Okay? So in this case, we ended up with actually 3 equivalent fractions, right? 3. But we want to just go ahead and mention the one we started with and the one we ended with. And if you were to type both of these in a calculator, for this one, you type 25 divided by 50. You would get 0.5. If you were to type this one, 1 divided by 2, you would still get 0.5. Or 0.50, whatever you want to call it. So again, they look different, but they have the same value. Okay? Look different, but have the same value. It's very important that you understand this. Okay? You're going to use this a lot this year. Okay? So we're going to go ahead and move on to our next example. Okay? It's our last one we're going to talk about. This one will help us get to into dividing decimal. Okay, so we're going to start off with our example. 37.9 divided by 5.3. 37.9 divided by 5.3. And so what we want to do is we actually want to understand that whenever we're using dividing decimals in a problem on paper, we don't want any decimals as our divisor. Okay, right now we have 5.3 as our divisor. We've talked about that. That's that denominator. We don't want that, right? Because it's not going to help us when we're doing division on paper. So, and of course you could type this in a calculator and get the answer real quick, but we want to learn how to do it on paper, right? By hand. So what we need to do is we need to move this decimal place over one time to turn it from 5.3 to 53, but we don't want to affect the whole problem, the fraction. So what do? We have to create an equivalent fraction. Okay, and the way we do that is we're going to multiply, and you probably heard this from your 5th grade teacher, 4th grade teacher. Whenever you multiply by 10, or something with a 10, 100, 1,000, those types of numbers, right, with the zeros in them, however many zeros you have, that's how many times the decimal place is going to move over. So if we multiply the bottom by 10, we got to multiply the top by 10 without changing our fraction, right? And so what we're going to end up with is 5.3 times 10. We're going to end up with 53, and 37.9. We're going to end up with 379 as our numerator. And so this is our equivalent fraction to this right here. Okay, so we start off with 37 and 9/10 in the numerator, 5 and 3/10 in the denominator, and then when we created our equivalent fraction, we ended up with 379 over 53. And if you type this in a calculator and this in a calculator, they will have the same value. They just look different. And that's the definition of equivalent fractions, okay? Thanks for watching, guys.